Hello viewers, welcome back to class. I'm super excited to welcome you guys back to Master Builders Online Academy. Don't forget this is a continuation class. So if you are new in this channel, please do consider subscribing to our channel and ensure that you turn on the post notification bell for more exciting videos when they uploaded. Understand that anytime you are set to watch videos from this platform, do not skip any part of the video and ensure that you avoid every unnecessary distractions anytime you are set to watch and learn from this platform. Don't forget to share this video, like this video, and make your necessary comments. Now guys, let's get to work. Now we have been observing the concept of differentiation of function in calculus for undergraduate students, purely for year 1 students who offers objectives in their examination. Now we are under higher derivatives. We have looked at other aspects of derivatives. Now we are looking at higher derivatives. Of course, when we started this lesson, I explained that we have derivatives in derivatives. For instance, if you are given any function, you can be asked to find or obtain the rate of change of that function in numbers of time. And I explained earlier when we started, we said differentiation is actually finding or obtaining the derivative of functions. So the derivatives of any function can be obtained more than one time. So when you obtain the derivative of any function more than once, then we term or call it higher derivative. So what are the instances or examples, or how do I know that I am dealing with higher derivatives? Now listen carefully. When we started, we said this is the y over the x. This is called first derivative, where d is 1 and this is 1. This is first derivative, and all that we have done so far is just to work on first derivative. Now, when you have d square y over the x squared, this is second derivative. Second derivative. Then if I have d cube y over the x cube, this is what? Third derivative. Just like that, if I now have the n y over the x, n, this is nth derivative. So that's what we have here now. Higher derivatives include the y square over the x square, d square over this, till d square n over the x square. So you can be asked to find the third derivative of any given function. So to find the second derivative of any function, it means you are to differentiate the given function 2 consecutive times. To find the third derivative of any function, that is to say, you are to differentiate the given function 3 consecutive times. If you are asked to differentiate or find the 10th derivative of any given function, that is to say, you are to differentiate that particular function 10 consecutive times. And if you are asked to find the 100th derivative of any function, it therefore means that you are to differentiate that particular given function 100 consecutive times. If this is understood, then we are good to go. Now, what else do you need to know? Understand that if I have the first derivative, obtain the second derivative, I will differentiate the previous derivative to get the current derivative. Listen carefully. To get the next derivative, differentiate the previous derivative, then you will get the next. It's just like that. So if I want to get the second derivative, I will differentiate the first derivative. If I want to get the third derivative, I will differentiate the second derivative. If I want to get the fourth derivative, I will differentiate the third derivative. That is to say, it is impossible for me to obtain the fifth derivative if I have not obtained first, second, third, and fourth. There is no way I can jump from any function. I just then obtain the fifth derivative without first obtaining the first, second, third, and fourth. So that is to say, every higher derivative depends on the other minimal derivative or the previous derivative. So if I have to find the 10th derivative, I will obtain the 10th derivative from the 9th derivative. If this is understood, guys, then let's quickly look at the questions that we have here. I just want you to understand it. With or without solving problems, with these basic explanations, I expect you to gain mastery over this answer. Now, let's use these questions as a backup to these theories and the principles I just gave. Because when you understand principles, like I do always say, you become a principal. And when you understand boundary conditions, you will not overstep your boundaries. Now, evaluate the following function. If a y is equal to this, we are asked to find d cube y over the s cube. That means we are obtaining the third derivative of this function. So we go down our solution. And for this, we have a y is equal to 5x4 plus 3x3 plus x squared minus 8. Now listen carefully, this question we are asked to find the third derivative. That means we will differentiate this y function 3 consecutive times. Are you there? We will have to differentiate this function 3 times. So first, we have the y over the x is equal to, now understand that this is a polynomial function, and you know what happens anytime you are differentiating a polynomial function or initial power. All I need to do now, bring that for 4 multiplied by 5. Now the power of the first term here is 4. So 4 multiplied by 5, this will have given us 20. X raised to power 3, we will reduce the power by 1. Then plus the next. The power of this variable here is 3. So 3 will multiply the existing coefficient, which is 3 multiplied by 3. This will give us 9. And we will reduce this by 1. This will have 2. Then also, we have the next to be s squared. When we differentiate s squared, we bring down the power, which is 2, and reduce the power by 1. And we don't need, there's no need to put 1. Then finally, when we differentiate constant, we know that is 0. So we have minus 0, which will make this to be our answer for the first derivative. Now the next is to obtain the second derivative. And this is equal to, now, to obtain the second derivative, you need to differentiate the result you have in the first derivative. So now I will now differentiate this function. I don't need to go back to this. I will now differentiate the first derivative to obtain the second derivative. Now, to differentiate this now, all I need to do is to identify the power, which is 3. 3 multiplied by the coefficient, which is 20, that would have given us 60. And then I will reduce the power by 1. It becomes 2. Plus, when I differentiate this now, I identify the power. The power is 2. 2 multiplied by 9, that is 18. Then when we reduce the power by 1, we have 1. Then when you differentiate 2x, guys, you have 2, because the power of x here is 1. This is the result we have for the second derivative. We will stop when we have reached the third derivative. So, to obtain the third derivative, we will now have to differentiate the second derivative. That's it. So, what do we have in our second derivative? To differentiate the second derivative, the first term here is 16s squared. And what's the power of the variable 2? So, 16 multiplied by 2, we have 120. When we reduce by 1, we have 1. Plus, when we differentiate 18x, we have 18. And when we differentiate 2, being a constant, we have 0. So, this is the answer to this question. So, the third derivative of this function is what we just have. It's as simple as this. So, with or without solving other problems, I know you can solve it. So, understand that current derivative depends on the previous derivatives. Now, number B. Question number 2, we have y is equal to sine 3x. And this is, we are asked to find the 4y over the s raised to power 4. This is what? Fourth derivative. That means we will have to differentiate this function 4 consecutive times before we can get our answer. And now the next thing we are quickly going to do is to identify what is this function. What type of function is this? Trig function. And it has a coefficient more than 1. And we recall that if we have sine ax, when we differentiate this, we have a cos ax. And equally, if we have cos ax, when we differentiate this, we have minus a sine ax. So you can go back to the standard table and have this refreshed in your memory. Are you there? This is it. Now, if this is understood, then we come here. if I differentiate dy with respect to x, I will have these 3 come out. Or see, this is how you do it. What was the angle here? The angle here is 3x. Just listen to what I'm going to do here. So just bring out the angle, which is 3x. When you differentiate 3x, you have 3. So put down 3. When you differentiate sine, you have cos. Now repeat the angle. This is first derivative. Second derivative must be obtained from the first derivative. Now listen carefully. So to obtain this now, all we simply need to do is to differentiate this. And understand that here we already have 3 existing as a coefficient. When we differentiate cos 3x, take out the angle which will give us 3x. When we differentiate 3x, we have 3. So we multiply this by 3. So we are going to multiply the existing coefficient here now again by 3. And now understand that when you differentiate cos, you have negative sign. So 3 multiplied by 3, you have. Then you now have sine 3x. This is the second derivative. Now, for the third derivative, this would have given us, we already have existing negative 9 as the coefficient of the sine. And this is what we are differentiating. And we understand that when we differentiate this, we will have 3 as the constant. When you take this 3x here and differentiate it, we have 3. So this 3, use it to multiply this. This will give us what? Negative 27. When you differentiate sine, you will have cos. That means this is negative 27 cos 3x. Don't forget the angle will never change. And finally, d 4 over dx 4 is equal to, now to obtain the fourth derivative, we have to differentiate the third derivative. Now in the third derivative, we already have a coefficient of negative 27. Multiply by, when we differentiate cos 3x, we will have this as negative 3 sine 3x, because the 3 will come out. Or when you differentiate 3x, you have 3. When you differentiate sine, cos, you have negative sine. So now, when we multiply negative 3 by negative 27, we will have positive 81. Then sine 3x. This is the answer to this question. When you understand principles, you become a master. You gain mastery suddenly with ease. And also, don't forget, when you understand boundary conditions, you will not overstep your boundary. So guys, if at this point you have not subscribed to this YouTube channel, please subscribe to our YouTube channel and ensure that you turn on the post notification bell so that you will not miss out of our mind-blowing content. Now, let's look at the next question, which is question number 6. We have that y is equal to exponent 1 minus 2x. Alright, so this is what we have. And we are asked to find what? The second derivative. So all we are looking for is the second derivative of this function. And to obtain the second derivative, you understand that you are going to differentiate this function 2 consecutive times. That's it. Now, listen carefully. Before you will differentiate this function, you must first of all identify the type of function that you have. Because we have several mathematical functions as explained in our previous lessons. Now we have this to be exponential function. And you understand that when you differentiate exponential function, the outcome you have is different from when you differentiate a trig function. If this is understood, all you need to do is to have dy over dx. Now, anytime you are differentiating an exponential function, the first thing you do is to identify the power of the exponential function. And what's the power? We have the power here to be what? 1 minus 2x. So you need to differentiate the power so that you will get the coefficient of the exponential function. When you differentiate 1, guys, you have 0. And when you differentiate minus 2x, you have 2. So 0 minus 2, you have negative 2. Now we are going to put down negative 2 and repeat the whole function that we were given. You can use bracket if you choose to. This is the first derivative. And understand, to find the second derivative, you need to differentiate the first derivative. It's as simple as this. Then all I need to do is to put down d squared 1 over dx squared is equal to, now, again, you will need to identify the power of the exponent, which will equally give us this. And when we differentiate it, this is the outcome. We are going to use this negative 2 to multiply this negative 2 here. And negative 2 multiplied by another negative 2, we have positive 4. Then we put down 4, then repeat the exponential function. This is the answer. So even though you are asked to find the 10th derivative, this is how the series will continue. You will always obtain the current derivative from the previous derivative. This is how it is. So D, y is equivalent to 2x plus 1 all raised to the power of 5, and we are looking for the third derivative. And now guys, how do we have this done? We are looking for the third derivative. In other words, it shows that we are going to differentiate this function 3 consecutive times. But before we will differentiate this function, we will need to identify what type of function is this. This is what we call function of a function or chain rule. And how do you differentiate chain rule? It's as simple as this. So first thing you do is to identify the power. Second, identify the function of x. So now, what is the function of x here? 2x plus 1. And what is the power? 5. So what we do, we have dy over dx is to first of all pull down the power, which is 5, multiply by differentiate the function of x with respect to x. When I differentiate 2x, I have 2. When I differentiate 1 being a constant, I have 0. So 2 plus 0, I have 2. Then I will multiply 5 by 2. And when I multiply 5 by 2, this will have given us 10. Then repeat the given question and reduce the power by 1. This will have given us. This is the answer for the first derivative. Now for the second derivative, just keep this one constant here, okay? Then we have this way, y over the s squared. We are to obtain the second derivative. I understand that the second derivative is obtained from the first derivative. Now we want to differentiate the first derivative to get the third. Now look at it. First, identify the power, which is 4. Put it here, multiply by, differentiate the function of x here, which is 2x. And when we differentiate 2x plus 1, we have to multiply this by 2, and this will have given us 8. We now need to multiply this 8 by the existing coefficient. And when we have this done, this will have given us 80. 10 multiplied by 8, we have 80. Now, we repeat this whole bracket, 2x plus 1, and reduce this power by 1. We have this to be 3. Then finally, before we round this up, we are asked to find the third derivative. And based on the concept that you have gotten here, we understand that the third derivative will be obtained from the first derivative, from the second derivative. Now, how do we have this done? All I need to do. Now, what is the existing coefficient here? Existing coefficient here is 80 multiplied by, what is the power? The power is 3. Now, differentiate the function of x, which we have as 2. And this will have given us 80 multiplied by 6. And this will give us 480. Then we put this as 480, open bracket. Now that, reduce the power by 1. This will have given us 2x plus 1 raised to the power of 2. This is the answer to this very question. It's as simple as this. Simple as ABC. Okay. Now, finally, we have question number E. And this is y is equal to cos, open bracket, 5x minus 3. And we are asked to find d5 over dx5. So for this question, we are asked to find the fifth derivative. And for us to be able to find the fifth derivative of this function, first, we must identify this function. That's the first thing. Now, the function that we have here now is a combination of trig and what a linear function. And this happens to be a question that can be solved under chain rule. Function of a function. And what do I do? All I need to do here first is to identify the function of x. And the function of x here is 5x minus 3. So quickly differentiate it. When I differentiate 5x, I have 5. When I differentiate negative 3, I have 0. All with respect to s. Finally, this is 5. All I just need to do now is have this y over dx is equal to this 5. Put it down. Alright? Put down this 5. Now understand that the next thing you're quickly going to do is to differentiate this trig identity. Anytime you differentiate cos, you have negative sign. So you have negative sign. Then repeat the given angle, nothing change. This is shortcut only for objective students. Here, 1 student, for other graduate students. Now, we want to obtain the second derivative, and we know that this is only possible with the first derivative. So we are going to differentiate the first derivative to obtain the second derivative. All you need to do now to meet up with time, you have already identified the function. Multiply this 5 by this 5. This will have given us negative 25. Put down negative 25. Now differentiate sign. When you differentiate sign, you have positive cos. Then repeat the angle. It's as simple as this. In one line, you have your answer. Then for the third derivative, this is possible when we differentiate the second derivative. So to differentiate this now, we already have an existing negative 25 as a coefficient. And understand that we are going to differentiate this. So when we differentiate, we already have this to be 5. 5 multiplied by negative 25, we have minus 125. And now when you differentiate cos, you have negative sign. So minus multiplied by minus, this will have given us positive 125 sine 5x minus 3. Angle remains unchanged. Then we are done with this. For the fourth derivative, we have the fourth y over the x4. And this is equivalent to now. When we put down the existing coefficient, multiply by, when we differentiate 5x minus 3, we have 5. When we multiply this, guys, this is 5. Multiply this by this, you have 10, 2. Multiply this by this, you have 625. So we will put down 625. Now differentiate the trig identity here. When you differentiate sign, you have positive cos. So this will not change the sign. Then we have 5x minus 3. Then finally, since we are looking for the fifth derivative, all we simply need to do is to differentiate the fourth derivative so we can get the fifth derivative. This is possible by first put down the coefficient of the derivative. Now when we differentiate 5x minus 3, we have 5. So you multiply this by 5. 5 multiplied by 5 is 5. Multiply by this is 10 plus 2. You have 12, carry 1. This multiplied by this is 30. Plus the 1 you carry, that's 31. So you have 3, 1. You pull down 3, 1, 2, 5. Now the next is when you differentiate cos, you have negative sign. Then put down your negative here, then put that sign, and repeat the given angle. This is how this question is solved. Now listen carefully. If you are to solve this particular question using the manual method, I tell you the truth, you will not use less than 2 pages of your Fusca sheet. You will use more than 2 Fusca sheets if you want to follow the conventional method. So this is the shortcut. Don't forget to subscribe to this YouTube channel if you have not done so. And ensure that you turn on the post notification bell for more exciting videos if you find our content helpful. I know you may not like to miss the next lesson. Now, as usual, you can check the description below where you will find the link to the next lesson. Don't forget to share, like, and make your necessary comment in form of questions, suggestions, and appreciation. We love you guys. Thanks for watching.